Good morning, sir. This is Tarun Kausik. Now, I would like to explain about the blowfish encryption algorithm in information system security. Now, coming to the blowfish encryption algorithm, blowfish is a key symmetric block cipher designed in 1993 by Bruce Skinner and included in a large number of cipher suites and encryption products. Blowfish is a symmetric block cipher that can be used as a drop-in replacement for DAS. Uh, so it is designed to use as a replacement for DAS algorithm. As discussed earlier, Blowfish was designed in 1993 by Bruce Skinner as a fast, free alternative to existing encryption algorithm. It takes a variable length key from 32 bits to 448 bits, making it ideal for both domestic and exportable use. Now, since then it has been analyzed considerably and it is slowly gaining acceptance as a strong encryption algorithm. Blowfish is unpatented and license free and is available free for all users. While no effective cryptanalysis of blowfish has been found to date, more attention is now given to block ciphers with a large block size such as AES or 2fish. At the time, many other designs were proprietary, encumbered by patents or kept as government secrets. Skinner has stated that blowfish is unpatented and will remain so in all countries. The algorithm is hereby placed in the public domain and can be freely used by anyone. So it is an open source algorithm and it can be accessed by anybody. Now let us discuss about the inventor of this blowfish algorithm, Bruce Skinner. Bruce Skinner is an American cryptographer, computer security specialist, and writer. He is the author of several books on computer security and cryptography and is the founder and chief technology officer of Counterpane Internet Security. The original blowfish. The original blowfish paper was presented at the first fast software encryption workshop in Cambridge, UK, and in 1994. Blowfish 1 year later appeared in the September 1995 issue of Dr. Dobbs Journal. There are mainly two parts in this blowfish algorithm. Those are a part that handles the expansion of the key and the second part that handles the encryption of the data. Now let us discuss about the two parts. So coming to the first part, the expansion of the key. In the expansion of the key, in this part, break the original key into a set of subkeys, specifically a key of number more than 448 bits is separated into 4168 bytes. There is a P array and 432-bit S boxes. The P array contains 18 32-bit subkeys, while each S box contains 256 entries. The encryption of the data. This is the second part. Now, in the encryption of the data part, 64-bit input is denoted with an X, while the P array is denoted with a pi. Now let us discuss about the blowfish algorithm key expansion. Blowfish has a 64-bit block size and a key length of anywhere from 32 bits to 448 bits. It's a 16-round Fiesel cipher and uses large key dependent S boxes. It is similar in structure to CAST 128, which uses fixed S boxes. Now let us discuss about the continuation of the blowfish algorithm key expansion. This diagram shows the actions of the blowfish. Each line represents 32 bits. The algorithm keeps two subkey arrays, the 18 entry P array and the four 256 entry S boxes. The S boxes accept 8-bit input and produce 32-bit output. One entry of the P array is used every round, and after the final round, each half of the data block is XORed with one of the two remaining unused P entries. If we observe the diagram, this action can be shown in this diagram. We can observe this action in this diagram. Now, after that, it initializes the P array and S boxes, XOR P array with the key bits. For example, P1 XOR P2, P1 XOR P2 XOR, like that. Use the above method to encrypt the all zero string. This new output is now P1 and P2. Encrypt the new P1 and P2 with the modified subkeys. This new output is now P3 and P4. Repeat 521 times in order to calculate new subkeys for the P array and the four S boxes. Here we can observe in this diagram about the previous discussed steps of the blowfish algorithm procedure. Now moving to the next slide. Here it is shown in the diagram of blowfish function, blowfish f function. Here we can observe. So in this there are four S boxes, and yeah, for each S box 8 bits are given as input, and after XORing the output, we will get is 32-bit from the each S box. The diagram of the right shows blowfish f function. The function splits the 32-bit input into four 8-bit quarters and uses the quarters as input to the S boxes. The outputs are added modulo 2 power 32 and XORed to produce the final 32-bit output. Since blowfish is a Feasel network, it can be inverted simply by XORing P17 and P18 to the ciphertext block, then using the P entries in the reverse order. Here we can see the function f, how it the working of this function f in this flowchart. First it will start, and then after that it will split the 32-bit input into four 8-bit quarters, and after that the XOR operation will carry out, and the whole thing we will do modules operation with 232, and then after that it will end. So this is the function f. Blowfish key schedule starts by initializing the P array and S boxes with values derived from the hexadecimal digits of pi, which contain no obvious pattern. The secret key is then XORed with the P entries in order. A 64-bit all-zero block is then encrypted with the algorithm as it stands. The resultant ciphertext replaces P1 and P2. The ciphertext is then encrypted again with the new subkeys, and P3 and P4 are replaced by the new ciphertext. This continues replacing the entire P array and all the S-box entries. In all, the blowfish encryption algorithm will run 521 times to generate all the subkeys. About 4 KB of data is processed. There is no effective cryptanalysis of blowfish known publicly as of 2005, although the 64-bit block size is now considered too short, because encrypting more than 232 data blocks can begin to leak information about the plain text due to a birthday attack. Despite this, blowfish seems thus far to be secure. While the short block size does not pose any serious concern for routine consumer applications like email, blowfish may not be suitable in situations where large plain text must be encrypted, as in data archival. In 1996, Serge Wadani found a known plaintext attack requiring 28 R plus 1 known plaintext to break, where R is the number of rounds. Moreover, he also found a class of weak keys that can be detected and broken by the same attack with only 24 R plus 1 known plaintext. This attack cannot be used against the full 16-round blowfish. Now let us discuss about the usage of blowfish in the practical world. Blowfish is one of the fastest block ciphers in widespread use, except when changing keys. Each new key requires preprocessing equivalent to encrypting about 4 kilobytes of text, which is very slow compared to other block ciphers. This prevents its use in certain applications, but is not a problem in others. In one application, it is actually a benefit. The password hashing method used in OpenBSD uses an algorithm derived from blowfish that makes use of the slow key schedule. The idea is that the extra computational effort required gives protection against dictionary attacks. In some implementations, blowfish has a relatively large memory footprint of just over 4 kilobytes of RAM. This is not a problem even for older, smaller desktop and laptop computers, but it does not prevent use in the smallest embedded systems such as early smart cards. Blowfish is not subject to any patents and is therefore freely available for anyone to use. This has contributed to its popularity in cryptographic software. Now, let us discuss about the products that use blowfish. Blowfish Advanced Series by Marcus Hahn. File encryption and wipe utility for all Windows 32 systems. File browser, job automation, auto password confirmation, secure key setup with SHA-1 and data compression with LZSS. Uses blowfish, twofish and arrow open source. These all are open source. 96 script by Feverlink. A file and folder encryption decryption program. Access Manager by City Software Limited. A password manager for Windows free for personal use. Edit. A free Windows word processor incorporating text encryption. Fullfish, an encrypting text editor for Windows. Hookchat, encrypted chat and advanced file sharing using a client-server architecture. JFile by LandJ Technologies, a database program for the Palm OS platform. Freedom by Zero Knowledge, privacy for web browsing, email, chat, telnet, and news groups. So to know more about these products that use Blowfish, you can refer this link of skinnier.com/blowfish-products. Now let us discuss about the advantages of this Blowfish encryption algorithm. It is faster than other encryption algorithms such as the data encryption standard DS algorithm. The Blowfish algorithm also has a lesser amount of operations to complete compared to other encryption algorithms. Now, the key schedule of this Blowfish algorithm takes a long time, but this can be advantageous as brute force attacks are more difficult. These are the advantages of this Blowfish encryption algorithm. Now let us discuss about the disadvantages of this Blowfish encryption algorithm. The key schedule of Blowfish takes a long time, equivalent to encrypting for 4 kilobits of data, which can be a disadvantage or an advantage. On the disadvantage side, it takes a very long time to do. So it takes more time for the encryption process. So which is it's a lot of time taking process. The small block size of Blowfish means that birthday attacks can occur and compromise the encryption algorithm. So there is a threat to this Blowfish algorithm by the birthday attacks. Oh, it is followed by Twofish, which was created to replace Blowfish as it is better in most ways. So people are shifting to Twofish encryption algorithm, and this Blowfish algorithm is losing its priority. So this is about this Blowfish encryption algorithm. Thank you.